So let's learn how to name alkenes. And this is your book's summary of the IUPAC rules for naming alkenes and cycloalkenes. I would actually prefer to switch the order of these first two rules. I think it's best to look first for the longest chain. You're looking at the parent carbon chain is going to be the longest continuous chain, and it has to include the double bond. So all alkenes are going to have at least one double bond. The double bond has to be in the chain. Based on that number of carbons in the chain, then you choose the name. You take the alkane name for a carbon, for something with that many carbons, and you change ANE to ENE. We'll do some examples, but we'll go through the rules first. You'll number the chain so that you start at the end nearest the double bond. If the double bond is right in the middle and there are some substituents on it, like a methyl group or something like that, then you're going to start from the end closest to the substituent. You'll give the position of the double bond as a single number. So the double bond is going to be between two carbons. So each of them is going to have a number. You're going to use the number you're going to use the lower number. If we have more than one double bond, then we specify that with by sticking a little prefix on the suffix. How's that? Diene, triene, tetrene, to indicate that there's more than one double bond. On cycloalkenes that don't have any substituents on them, and there's only one double bond, we don't need to specify our number because it's a circle, and we'll just start at the double bond, and it would always be between 1 and 2. If you have when you have a substituted cycloalkene, you're going to number those double bonded carbons so that you get the lowest number on the first encountered substituent. And again, these rules, when you just list them off, don't make a lot of sense. They'll make more sense when we do some examples. If you have more than one double bond in your cycloalkene, again, you're going to try to get lowest numbers. So one of the double bonds is going to be 1 and 2, and then you're going to choose that so that the other double bonds get the lowest numbers possible. So let's practice this a little bit. So assign IUPAC names to the following alkenes and cycloalkenes. So let's look at this first one. We need to figure out what the longest chain is, and the longest chain has to have the double bond in it. So here's the double bond, and it looks like it's going to be 1, 2, 3, 4, 5, 6. And if we include this guy, it's still 6. So our longest chain is 6. 6 would be hexane, but there's a double bond, so this is hexene. So that's the base name is hexene. Then we need to identify where is the double bond. So we have two choices in numbering. We can start from the left, and that would have the double bond starting at carbon 2, or we can start at the right, 1, 2, 3, 4. The double bond would start at 4. We want the double bond to have the lowest number. We have a substituent here. We have a methyl group. The double bond takes precedence over the methyl group. Okay, so the double bond gets the lowest number, and the methyl group gets what's left over. So we're going to number this from left to right. 1, 2, 3, 4, 5, 6. And the double bond starts on carbon 2 and goes to carbon 3. So we always give the number that it starts on. So this is 2-hexene. 2-hexene. 2 tells us where the double bond is. Ene tells us there's a double bond. Then the substituent is this guy right here, which is methyl. So that goes in front, and we always separate numbers and letters with a hyphen. So there's a methyl here, and the methyl is on carbon 5. So that's 5-methyl 2-hexene. Isn't this fun? Some people do find this fun. Any questions about that one?
So it's just important to name the first carbon that's connected to the double bond? Because we didn't use 3 at all.
Right, we don't use 3 because we're numbering consecutively. So if it starts on 2, the second one has to be 3. Yeah. So in a lot of these things of how we name stuff, we're looking for to be descriptive, but also to be concise and to not write a lot of stuff that we don't need. Any other questions about A? Okay, let's look at B. What do we have going on here in B? Well, in B, we have a ring, don't we? The ring has 6 carbons, and there's a substituent over here that has 2, and this one has 1. So the ring is the biggest thing going on. So the ring is the base, the parent chain. So 6 carbons in a ring would be cyclohexane, right? But there's a double bond, so this is cyclohexene. Cyclohexene. It's kind of like a code. Cyclohexene. And we have to identify where the double bond is because we've got 2 substituents here. This guy is a methyl group. Methyl. And this guy up here is an ethyl group. So we're going to have to give those guys numbers as well. Numbering this ring, we're going to start at one end of the double bond and go either clockwise or counterclockwise. Now if I start at here, that would be 1, 2, 3, 4. This guy would get a 5. That guy would get a 6. So those are pretty high numbers. If we start at the other end of the double bond and call this 1, 2, 3, 4, 5, 6, then our substituents are going to get lower numbers. So that's the direction that we want to number it in. The double bond is always going to be number 1.
And then why did you put the cyclo in front of it?
Because it's a cyclic compound. There's a ring.
Okay.
Yeah. So this guy has a straight chain, and this one has a ring. And so the ring has the prefix cyclo. What I did here. Now here's a question. Do we need to specify where the double bond is? We don't. Because the double bond always gets the lowest number. We always start the double bond as number 1. So it's always 1 cyclohexene if there's only one double bond. And because it's always 1, we're not going to write the 1. Because chemists would rather not write the number 1. We just avoid it all the time. So it's not 1 cyclohexene, it's just cyclohexene. Then we have to identify where the substituents are. We've got ethyl and methyl. And which one are we going to put first? Ethyl. Why? Alphabetical. Okay, so ethyl is 3. so hopefully I can gauge how much space this is going to take. 3 ethyl and 4 methyl cyclohexene. Any questions? Okay, let's look at, oh, that was, oh, nice. I've got 2 B's. Excellent. Oh, well, we'll call this one C. I don't know what it is in the book. Let's look at C. What's the longest chain here? 4 carbons. So 4 carbons is butane, right? But this would be butene. But how many double bonds does it have? It's got 2. Okay. So then it becomes butadiene. So this is butadiene. The di gets in there because there's 2 double bonds. Where did the A come from? Well, if we left the A off, it would look like butadiene or something. We need a vowel in there, so we left the vowel from the butane. That's my best explanation for that. Well, where are the double bonds? Well, we have to number this, and it's going to be the same either way, isn't it? So I prefer left to right if they're the same. So I'm going to call this 1, 2, 3, 4. So the first double bond starts on the 1, the second double bond starts on the 3. So this is 1,3-butadiene. Are there any other substituents on there? No. So that's 1,3-butadiene. Any questions? Okay, let's look at this last guy. What's our longest carbon chain? 5. Pentane. It's in a circle, right? So this is a cyclopentane, and it's got 2 double bonds, so it's cyclopentadiene. Cyclopentadiene. Now we have to decide how to number this guy. Oh great, the answer they gave in the book is wrong. They left off the cyclo. Good grief. Not that I don't make mistakes too, because I definitely do. Well, we have to start numbering this at one of the double bonds. And sometimes you can look at it and just see where to start, and other times you just have to kind of start and see how it goes. So let's just start here. Let's go 1, 2, 3, 4, 5. So we're going to have a 1 and a 4 for the double bonds, and a 3, this is a methyl group, right? That's a substituent. So that's 1 and 4. So let's see what would happen if we do a different way. Let's try starting here. 1, 2, 3, 4, 5. Well, that gets us 2, 4, and 5. That's worse, right? So I'm going to get rid of those because that wasn't right. We could start here and go 1, 2, 3, 4, 5. Then we end up with a 1 and a 3 and a 4. And that's the same thing we had before, isn't it? Let's see. 1, 2, 3, 4, 5. That's worse because we still have 1 and 4 for the double bonds, but then the methyl group gets a 5 instead of a 3. So it's going to be 1,4 cyclopentadiene. 1, 4. And it's got a methyl group on the 3. There's not much space. We'll angle this up. Wow. In the book it says 5-methyl-1,3-pentadiene. Can you get a 1,3? Because 1,3 would be better. Maybe I missed something. 1, 2, oh, I did something. I missed it. Okay. My bad. I missed a possibility. I'm just going to erase all of these because it's getting very muddy in there. If we start here, which I forgot to look at, 1, 2, 3, 4. Okay, 4, 5. That gets us lower numbers on our double bonds. I missed that one. So that is better. Even though the methyl group is a 5 now instead of a 3, the double bonds are more important. So we're going to get lowest numbers on the double bonds. The other substituent comes into play only to break a tie. If you've got different ways of numbering that are the same for the double bonds, like the other two ways I found that were 1, 4, then the methyl would break the tie. So this is 1, 3. And the methyl would be on 5, so 5-methyl.
Yeah, I've got the earlier edition, that's the way it has it.
Yeah, this one says 5-methyl-1,3-pentadiene. What it's missing is it's cyclopentadiene.
Oh,
Yeah. Any questions? This isn't, like my kids say, it's not rocket surgery, but there's a lot of little things, there's a lot of little details. And so it's not obvious and straightforward either. You sometimes have to look around, and you definitely have to practice and make sure that you're doing it correctly, and you kind of get a feel for it after a while. There are also some common names for IUPAC, common names for alkenes. And these are non-IUPAC names. And it would be so much easier if we could just put these in the past, but we can't. People are just really stuck on them. Suppose it's a little bit like, you pick up a nickname as a kid. I know a guy, he's roughly my age, and they called him Tiger when he was a kid. People still call him Tiger, I think he's 50, and people call him Tiger. His name is James, but everyone calls him Tiger. That's his nickname, his common name. It's not his given name, but it's still in use. So some of these compounds have common names that are actually used much more often than the IUPAC names. So we need to know how to do the IUPAC names, but there are a few of these that we have to also know the common name. So these are the ones that show up in the slides are the ones you need to know. So there are two alkenes, the smallest ones here, that have common names. So this is ethene, is his IUPAC name, but the common name is ethylene. At least the names are similar. So this is ethylene, and the IUPAC name is ethene. This IUPAC name would be propene. It doesn't have a number for the location of the double bond, because either way, If you put the double bond over here, it's still 1. So there's only one possible isomer here. So this is propene, the common name is propylene. So if you're given, write the structure for propylene, then you need to know what that is. So in chapter 1, we talked about alkyl substituents, which were alkane groups that were attached to a larger parent chain. Alkenes also can also be substituents, and they're called, instead of alkyl groups, they're called alkenyl groups. So these are the most frequently encountered. We're only going to deal with these little guys. So this is methylene. That's its common name. Its IUPAC name is methylidine, which is almost never used. This is vinyl, and its IUPAC name is ethenyl. And this is allyl. I don't know where they got that. The vinyl and the allyl, those are like coming out of nowhere. Sorry. That they were calling them that before I was born. The IUPAC name would be 2-propenyl. So propene, let's draw. Propene is this guy. This group is called 2-propenyl because of where it's attached. When it's a substituent, you have to number the carbon that's attached to the chain as carbon number 1. So this becomes carbon number 1, and now the double bond is on the second carbon. That's why it's called 2-propenyl. This is propene. So when these are substituents, here's an example. This is cyclopentane, and it's got this guy attached to it. So this is methylene cyclopentane, or methylidine, sorry, blanking out. Methylidine cyclopentane. Here we have the vinyl group. The vinyl group attached to chlorine. We did 2 different ways of naming alkyl chloride halides. So like this is a methyl group. So this can be called methyl chloride, or it can be called chloromethane. Chloromethane is the IUPAC name. So the IUPAC name for this guy is, we think of the carbons as the parent. So that's ethene, and it's got a chlorine on it. So chloroethene. The vinyl is the common name, and so then we have to use that with the common way of naming these halides. And here we're focusing on the chlorine as the parent, and this as being attached to the chlorine. So this is a vinyl group, so it's vinyl chloride. And this guy over here, this is the allyl group attached to bromine. So allyl bromide. The IUPAC name is 3-bromopropene. So we have this as being propene with the carbon starting on number 1, and the bromine is attached to that.